Hi there, welcome to this video. My name is Pushpinder Gill, and let's go ahead and get started with this video here. So today we're going to be talking about complex numbers. Right? So let's suppose if I start with an example, if I say, let's suppose x squared plus 1 is equal to 0. So if I kind of draw this function out on the on the graph here, then I'll have x squared to be equal to -1, which if I take this 1 to that side, and from here I'll have a very unusual value of x. The value of x is going to be equal to under root of -1. Well, this is something which is very unusual. And as you can clearly see here, this -1 is kind of stuck there. It's kind of stuck in the root because it cannot come out. The only thing that can come out of a root is as actually a positive number. A negative root cannot come out unless it actually multiplies with other negative number or divides with other negative number and becomes a positive number. So what is this denoted as? So this is something which is denoted by I, which is known as the complex number. This is something which is known as the complex number, right? Now, this is what a complex number is, that is under root of -1, right? And it's actually an imaginary number, something that we have imagined from our own side. So it's actually an imaginary number. Now, this number has certain properties that we are interested in here. So let's actually learn the properties of these imaginary numbers. In this video, we're going to be talking about the basic properties. We'll cover a lot, but then we'll move forward to some advanced properties of complex numbers. Now, the first property that I would like to talk about, it's actually the square of this complex number. So if I know I is equal to root of -1, then I square, if I kind of square this up, so this is going to be root of -1 into root of -1, that will turn out to be equal to -1. So the first property that I'm interested in is that the value of I square is actually equal to -1. Similarly, if the value of I square is equal to -1, then what will be the value of I to the power 3? That is going to be I times I square, which is equal to a -I, right? That is, in terms of mathematical terms, it's a negative of under root of -1. And what about I to the power 4? I to the power 4 is going to be square of I square, which is going to be -1 raised to the power 2, because I square is actually -1. So -1 raised to the power 2 is going to be equal to +1. So this is the first property that we are interested in, that is the various identities or the various properties of y. Now let's go ahead and learn about the second property. So let's say someone asks me the value of, what is the value of, so I'm just going to use an example here. Someone says, what is the value of I to the power -79? So that is going to be 1 by I to the power 79, because this negative power will take it to the denominator. And I can actually break this up as 1 divided by I to the power 4 raised to the power 19, which is I to the power 19 times 4, which is equal to 68, into I, which is actually equal to 78, plus which into I to the power 3, right? So if I kind of open this up, 19 times 4, so 19 times 4 is equal to 76, 76 plus 3 is 79. And from here, as we already know that I to the power 4 is equal to 1, so it's going to be 1 into I to the power 3, and we know that I to the power 3 is -I. That means from here I have 1 over -I. And how to actually bring this I to the top way? I can say, what I can do is I can actually multiply by I to the power 3, and I can actually divide by I to the power 3. So this will give us I to the power 3 divided by I to the power 3 into a -I, which is negative of I to the power 4. And as we already know that the value of the I to the power 4 is 1. So this is nothing but negative I to the power 3. And what is I to the power 3? It's negative of I, and negative of I is going to be positive of I. So these identities help us to do questions like these whenever they come, right? So, I suppose you're getting this point over here. Let's go ahead and learn the second property on the complex numbers. So the second property that I want to talk about of a complex number is that a complex number is of a general form. The general form of a complex number is x plus iy, right? So this is actually a complex number here, right? And this number has actually two parts. If I say x plus iy, this part is known as the real part of the complex number, and this part is known as the imaginary part of the complex number, right? So if I have to equate, let's suppose if I pick up the value of 3 plus 2i, right? So this 3 is actually the real part of a complex number and 2 is the imaginary part of a complex number. If this is actually equal to some complex number a plus bi, then from here I can say that the value of a is equal to 3 and the value of b is equal to 2. So from this I can equate and say that the value of a is equal to 3 and the value of b is equal to 2. Similarly, if I have a complex number that a plus bi is actually equal to c plus di, then used from this expression, I can say that a is equal to c and b is equal to d, right? So this is the second property of complex numbers, right? So, I suppose you're understanding this point over here. Let's move on to the next property, guys. The next property is about the addition and subtraction of complex numbers, right? So the addition and the subtraction of complex numbers. So if let's suppose I want to add two complex numbers. Let's suppose one complex number is 3 plus 4i and other complex number is actually 5 plus 6i, right? So what I'll do is when I add the complex numbers, I'll add the real part separately. So it's going to be 5 plus 3, 8, and I will add the imaginary part separately, 6 plus 4, which is 10i. So this is what is going to be the complex number. So generally, if I talk about, let's suppose a plus ib is actually added to c plus id, then from here I can say that the real numbers is going to get added and plus the imaginary numbers are going to get added, and this is what I'm going to have. Similarly for subtraction, if let's suppose I'm going to subtract this complex number from this complex number, then again the real numbers are going to get subtracted separately and the imaginary numbers are going to get subtracted separately, right? So I suppose you're understanding this point over here, guys. So let's suppose if I want to say, let's suppose I use an example here. And we go ahead and we add a few complex numbers. That is that let's suppose we want to add this identity here, that is 1 minus I to the power 7 plus 5i square plus I. Let's suppose we want to add that. So first of all, what we'll do is we kind of bring this down to the normal level. So what is I to the power 7, right? So I'm just going to say, what is I to the power 7? That is going to be equal to I to the power 6 into I, that is equal to I to the power 7, which is going to be I to the power 2 raised to the power 3 into I. And what is I to the power 2? That is actually equal to negative 1. Negative 1 raised to the power 3 into I. So this is going to be equal to negative I. So this over here is going to be negative I. And 1 minus negative I is going to be 1 plus I. Similarly, 5 into I square. So what is the value of I square? So this is 1, I'm sorry. So what is 5 into I square? That is negative 5 plus I. So at the end I have 1 plus I and minus 5 plus I. And what I'll do is I'll add the real values separately and I will add the other values separately, the imaginary values. And from here I'll get negative 4 plus 2i, right? So kind of reinstating what I just said here is about the addition and the subtraction of the complex numbers. So I suppose you've understood this, and it's very easy. You don't have to launch any rocket for it. So it's actually a very easy thing. So let's move forward and let's kind of make things a little bit more difficult. Let's move on to the next property of complex numbers. So in this property, that is actually the fourth property. In this property, let's actually understand the multiplication of complex numbers, right? So we're going to understand the multiplication of complex numbers. So let's suppose you have a complex number a plus bi, and you have another complex number that is c plus di. right? So let's suppose you have these two complex numbers and you want to multiply them. Then as you already know that this A will get multiplied by this C, this A will then get multiplied with this D. You'll have ADI, and you have B getting multiplied with this C, and you're supposed to write the I before uh, IBC, and this B will get multiplied with this. So I into I is going to be I square. I'm just going to write like this, into B into D, right? If you kind of open this up, you'll have A into C. This I square is going to become a negative number. That is going to be minus B into D. And then you can take I common out of there. So you're going to have I here. That again over here is going to give you A into D plus B into C. So that's actually how you multiply any two complex numbers. Either you can remember this expression or you can actually every time multiply this way. I prefer it to multiply it this way. I don't want to remember these expressions here, right? So another thing about the multiplication of these complex numbers, which is actually a little thing that you have to remember, it's the multiplicative inverse. Now, what is a multiplicative inverse? Let's suppose if there is a number x, right? If there's a number x and I want to find the multiplicative inverse of this number x, that is going to be 1 by x, because so that any number whenever multiplied with its multiplicative inverse is going to give the product as 1 all the time. So if a number x is there, its multiplicative inverse is going to be 1 by x. So let's suppose if I want to find the multiplicative inverse of this complex number a plus ib. Now, if I want to find the multiplicative inverse of this complex number, I'll say 1 over a plus ib. And remember one thing, it's kind of, not good that you keep a complex number in the denominator. So what I'm going to do is I'm going to rationalize this thing here. So what do you mean by rationalizing? I'm going to multiply this by a minus ib, and I'm going to divide this by a minus ib. Why did I do that? I wanted to eliminate the I from the denominator. So which is why I rationalize it. I multiply it by a minus ib and a minus ib, and divided it by a minus ib. So using this over here, you see this is something of a nature of a plus something and a minus something, which will result in a square minus b square. Right, so that is something that's going to result in a square minus b square. Even if you solve it this way, you're going to get a square minus b square only. So I'm going to have a minus ib over a into a, that is a square, minus b square. So if you see b square, you have I square here into b square. So this is something which is going to become a minus ib divided by, so this is something which is a square, and I square is actually a negative number, and a negative number into negative number is going to give you a positive number, and then you have b square over here, which means if you kind of break this up again, because it's kind of jinx to keep a complex number together with actually a real number. So if I break this up, I can say a minus ib over a square plus b square can actually be written as a divided by a square plus b square, and minus I into b divided by a square plus b square, right? So this is actually the multiplicative inverse of any complex number. So let's suppose if I use an example here. Let's suppose I use an example that let's find the multiplicative inverse of 3 plus 4i, right? So the multiplicative inverse of 3 plus 4i is going to be 3 over under root of 3 square plus 4 square, and minus I into 4 over under root 3 square plus 4 square. So which is going to be 3 over 5 minus I 4 over 5. So this is going to be multiplicative inverse of this, which means this into this is going to give me 1. That is what is the meaning of a multiplicative inverse. So I suppose you're understanding this point over here, guys, and moving forward to the next thing. So now let's get to the next property. Since we've talked multiplication, let's talk about the division of a complex number. So how do you actually divide a complex number? So let's suppose I have two complex numbers, that is a plus ib, and I have another complex number. Let's suppose this is denoted by z1. Another complex number is let's suppose c plus id. Now let's suppose if I want to find the division of these two complex numbers, and I want to do a plus ib over c plus I into d. Now, whenever you have this kind of division here, first of all, the first rule is to get rid of this I here, because you don't keep complex numbers in denominators. So what you'll do is, again, you'll rationalize this. And how do you rationalize this? Is by multiplying the conjugate of of the denominator. So it's c plus id. So you multiply the conjugate of this by a numerator and denominator. So you're gonna have c minus id and c minus id. So that is there. What is the conjugate? Conjugate of a complex number. Let's suppose you have a plus ib. Then conjugate of a plus ib is going to be equal to a minus ib. So let's suppose you have a complex function that is c plus id. So what is the conjugate? That is z bar. That is c minus id. So that is how you actually rationalize a complex number here. So over here again, the division is actually going to come out to be equal to, so you'll have nothing but a plus ib into c minus id. And you can actually multiply this up. So if you multiply this up, it's going to come down to ac plus bd. That is what is there, and plus bc minus ad. This whole thing will get multiplied by I, right? And c plus id into c minus id is nothing gonna be c square plus d square, as we've already seen in the previous example here, that a plus ib into a minus ib came out to be a square plus b square. So c plus id into c minus id is gonna be c square plus d square. So this is actually going to be the division, that is ac plus bd. I'll just keep the real numbers and the imaginary numbers completely aside when it comes to complex numbers. That is a habit that you'll have to develop, right? So this is what is there. It's the division. How do you divide two complex numbers, right? So let's suppose if you want to use an example, and if we want to use an example, and we want to find out the value of 2 plus 3i over 2 minus 3i. So what we're going to do is we're going to multiply this by the conjugate of the denominator. We're going to multiply it by 2 plus 3i and 2 plus 3i. And this is nothing but it's going to be a square plus b square plus 2 into a into b. So 3 into 2 is 6. 6 into 2 is 12. And you have another I square at the front, right? So that is there. So you're just going to have an I here because it's 2 into a into b. It's 2 into 2 into 3i divided by a plus b into a minus b, which is going to be, again, this is something which is going to be a square plus b square. So this is going to be 2 square, which is 4, and this is going to be 3 square, which is 9, right? So then over here, what is that you're going to have? You're going to have so this is going to be 4, and this over here is going to become negative 9 because of an I square here. So negative 9 plus 12 times I divided by 13, and then your value is going to be equal to negative 5 by 13 plus 12i by 13, right? So this is actually an example, a simple example of a simple division function. So I suppose you're understanding the property of a complex number here, that when you divide by a complex number, what actually happens. Now let's go ahead and find the next property of a complex function. So the next property of a complex function, it's actually about the modulus or the absolute value of a complex function. We're going to be doing the derivation of this property in the future videos. So in this property, I'd like to tell you that if you have, let's suppose, any two numbers, let's suppose a and b, which are actually real numbers, and you have a complex number, let's suppose z is equal to a plus ib, then the modulus or the absolute value of z is going to be equal to under root. Now, since absolute values are always positive, and they're always positive, so to make sure that you get a positive number here, that is going to be root of a square plus b square, right? So we're going to do the derivation of this in the future videos, that's for sure. But for now, what I like to tell you is that the modulus or the absolute value of a complex number is actually equal to root of a square plus b square, right? So let's suppose if you want to find the absolute value, let's suppose we want to use an example here. Let's suppose we want to find the absolute value of 12 plus 3i. So the absolute value of 12 plus 3i is actually going to be equal to under root of a square plus b square, which is a square, which is 12 square, plus b square. So this over here is going to be the absolute value of this modulus, sorry, so of this complex function, right, or a complex equation. So, I suppose you're understanding this property of modulus functions, sorry, a property of complex equations. Let's move forward to the next one. Now in this property, this is the property about the square root of a complex function. Now, how do you find the square root of a complex function? Let's suppose, I want to define a complex function that is a plus ib. And I am interested in finding the square root of this complex function. Let's suppose the square root of this complex function is another complex function that is, x plus iy, right? Let's suppose the square root of this complex function is actually another complex function, which is x plus iy. What I can do here is, if I kind of square both sides up, right? I'm interested in finding x plus iy in terms of a plus ib. If I kind of square both these things up, so I'll have a plus ib to be equal to x plus iy, right? So from here, I actually went to this step, right? So from here, we can act x plus iy whole square, right? So that is there. And if I kind of open this up, what I'll have is I'll have a square, which is x square, plus b square. So this I square is going to become negative, minus y square, plus 2ab, which is 2ixy, or I2xy, better way of saying that, right? Just get that. All right. So I'll just change this to xy. Oops, I erased it all. Let's just start again for this. I want to find the square root of a complex number, right? So let's suppose our complex number is actually equal to uh, x plus iy, right? So let's suppose our complex number is x plus iy, and I'm interested in finding the square root of this complex number, which is, let's suppose, is equal to a plus ib. Now what I'm going to do is I'm going to square both sides up here, and if I square both sides up, I'll get x plus iy here, and that is going to be equal to this function here. So if I kind of open this up, it's going to be a square plus b square plus 2ab, which further is going to be equal to a square, and this I square is going to become a negative 1, that is negative of b square plus I into 2ab, and this is something which is equal to x plus iy, right? So this is something which is equal to x plus iy. So from here you'll be able to say that this x is actually equal to this, the real part is equal to the real part, and the imaginary part is actually equal to the imaginary part. So from here, the next step is going to be that the value of x is actually equal to a square minus b square, and the value of y is actually equal to 2 times a times b. However, I'm interested in finding the real values of x in terms of a and the values of y in terms of b, right? So that is actually what I'm interested in finding. So what I'll do over here is that, so if I want to equate the value of a in terms of x, so if I have a square minus b square, I'm actually interested in finding the value of a square plus b square. So if I kind of square this up from here, if I kind of open this up, this over here is going to be equal to a to the power 4 plus b to the power 4 plus 2 times a square and b square. And what is actually equal to the value of a square minus b square. So a square minus b square raised to the power 2 is going to be a to the power 4 plus b to the power 4 minus 2 times a to a square and b square, right? So if I say, how do I get a square plus b square in terms of a square minus b square, I can say that, using this expression, I can say that a square plus b square raised to the power 2 and plus a square minus b square raised to the power 2 it's going to be equal to, okay, if I kind of subtract these values rather than adding these values, then so you can clearly see this and this will get eliminated. So a square plus b square raised to the power 2 minus a square plus b square raised to the power 2 is going to be 2 plus 2, that is 4a square into b square, which is actually equal to 2ab whole to the power 2. Now this is where things get interesting, that a square plus b square raised to the power 2, and you already have the value of uh, a square minus b square. So what is a square minus b square? That is already equal to x. So gonna have minus x to the power 2 is equal to, so 2ab is already equal to y, that is equal to y to the power 2. So from here I'm gonna have a square plus b square raised to the power 2 is actually equal to x square plus y square, right? So a square plus b square raised to the power 2 is actually equal to x plus y square. So from here I'm gonna get a square plus b square to be equal to under root of x square plus y square. So what do I have? I have a square plus b square to be equal to under root of x square plus y square. And from here I have a square minus b square to be actually equal to the value of x. Now from here I'll be able to get the value of a and b very easily. How is that? Let me just take these two expressions on the next page here. I have the value of a square plus b square to be equal to under root x square plus y square, and I have the value of a square minus b square to be equal to x, right? So if I kind of add both these equations up, if I kind of add both these equations up, I'll get a square plus a square is equal to 2a square, that is equal to x plus under root x square plus y square. And from here a square is going to be equal to x plus under root x square plus y square divided by 2, and the value of a is going to be equal to plus minus under root of y plus minus, because of kind of raising both the sides to the power 1 by 2, then this is going to be plus minus x plus x square plus y square under root divided by 2. Now this over here is actually equal to the value of a, that is plus minus under root x plus x square plus y square divided by 2. And what about the value of b? So we already know that the value of 2 times a times b is actually equal to y. Hence, since we know the value of a in terms of x and y, once we find the value of a, we'll be able to find the value of b as well. So the value of b is going to be equal to y divided by 2a. So that means for a complex function x minus ay, the under root is going to be equal to a plus ib, where a is equal to plus minus under root of x plus under root of x square plus y square divided by 2, and b is nothing but y divided by 2. So these are this is the expression. How do you find the under root of a complex equation? So we're going to use an example here, right? We're going to go ahead and find the square root of a complex equation, right? So let's go ahead and find that. So let's suppose we want to find, just going to write this as an example. We're going to find the square root of 7 plus 24i, right? So we have to find the square root of 7 plus 24i. Let's suppose the square root is actually equal to a plus ib, right? So let's suppose the square root of this is actually equal to a plus ib. Then you're going to follow the same process. What you're going to do is you're going to square both sides up. Then you're going to get, I'm just going to divide the screen into two parts here like this, right? So, and you'll have 7 plus 24i to be equal to a square, a plus ib whole to the power 2, right? Which is actually going to be equal to a square minus b square plus I into 2ab, right? So if you kind of open a square plus ib square, you get a square plus b square into I square, which is negative, plus 2aib, right? So that is what you have. So you have the value of a square plus b square to be equal to, not a square plus b square, a square minus b square to be equal to 7. You have the value of 2ab to be equal to 24, right? So you have a square plus a square minus b square to be equal to 7. You have 2ab to be equal to 24, which means you have ab to be equal to 12, right? So that is something that you have. So you're going to use the same expression here. Now you have the value of a square minus b square. All you need to do is get the value of a square plus b square. So if you kind of square a square plus b square, you're going to get if you kind of square a square plus b square, so you're going to get a square, a to the power 4 plus b to the power 4 plus 2 times a square b square. So that is what you have here, right? And if you have a square minus b square raised to the power 2, so you're going to have a to the power 4 plus b to the power 4 minus 2a square b square. So if you kind of, again, I think you can remember this expression up from here. You get a square plus b square whole to the power 2 to be equal to a square minus b square plus 4a square b square. So at the end of the day, you will have the value of a square plus b square whole to the power 2 to be equal to, so you already have the value of a square minus b square, which is 7 square, which is actually, this is 7 square. And this over here, it's 2ab square, which is actually 24 square. So this is 24 square. So 7 square plus 24 square is 49 plus 576, which is actually equal to 625. Which means from here, I'm going to get the value of a square plus b square to be equal to 25, right? If a square plus b square is 25, a square minus b square is actually equal to 7. Then I can actually find two different values. You know, from here, I can actually get two different values of a and b. So from here, if I kind of use this expression here, a square plus b square is 25 and a square minus b square is actually equal to 7. If I kind of add both these equations up, I'll get the value of a square plus a square, which is 2a square, to be equal to 25 plus 7, which is equal to 32. From here, I'll get the value of a square to be equal to 16. If a square is 16, then a would be equal to 4 or a would be equal to negative 4. If a is equal to 4, and we already know that a into b is actually equal to 12, that means b is going to be 3 here and b is going to be equal to negative 3 here, right? So that means you have two functions. The under root of 7 plus 24i in this case is going to be equal to 4 plus i3, and over here the under root of 7 plus 24i is equal to negative of 4 plus i3. So that means you can say that the under root of 7 plus 24i is equal to plus minus 4 plus i3. So this is how you actually find a square root of a complex number, right? So I suppose you've understood what we've done here, guys, and this would be what the video. Thank you very much for watching. Thank you very much, guys, for watching this video, right? This would be our website, that is perfect-scores.com, where you can explore more about us. Lots of exciting stuff here. Keep on watching this website. This would be the Facebook page, where you can give us your valuable like, and don't forget to send us your valuable feedback. We love to have your feedback and everything on perfectscores89@gmail.com. So this would be what the video, guys. Thank you very much for watching, and I'll see you in the next one.